Hi everyone, I'm David from the Saito project, and this video is about the free rider problem in blockchain, and more importantly, how to fix it. Now, if you're not familiar with the free rider problem, it is a known type of market failure. What this means is it's a situation where if you leave the private sector to its own, you just get a really suboptimal outcome. Now, economists have known about this since the 1950s. This is not new. If it's new to you, the way to understand it is that it's an incentive problem. And the problem is that the private sector does not really easily provide things like lighthouses or national defense, these class of goods that have non-excludable benefits. And if you stop to think about it, well, it makes sense why. Because markets need to control the distribution of benefits in order to induce people to pay for them. So if you're producing something that everyone can enjoy, you have a really hard time convincing someone to pay you to help cover the cost. And this is why the traditional solution in economics is to privatize things, where if you put a good under someone's private control, all of a sudden they have an incentive to manage it. Now, the relevance of this to blockchain is that the public network in any blockchain is a public good. Very few people talk about this. Not very many people are actually aware of this, but the problem is that you need a network layer that shares data, and that network layer needs to provide shared, open, public access to the data flows in order for the consensus mechanism that feeds off it to remain secure. If you ever have a system where the network layer becomes privatized and people are deciding who transaction fees flow to, or if you have the network layer that decides who gets access to the data that is needed to participate in consensus, you've just destroyed your blockchain. You've just destroyed the open, public nature of the blockchain. And what you're doing, we're seeing this actually play out in real life. We'll get to that in a bit. What we're seeing is that as blockchains scale, these economic problems are turning them from real public chains into quasi-permission chains. And it's only going to get worse. But where this gets us is that the scaling challenge fundamentally is an economic problem of how do we pay for the network? And there are three basic philosophies. You'll hear often from BTC, Bitcoin Core developers that, well, we can't scale, they say. We can't scale because if we scale, volunteers won't pay for the network. So that's the most pessimistic view. We've got two optimistic views. One we like to associate with BSV because you'll hear it often from those network developers. And they'll say, we treat miners as the center of the economy, and so miners will pay for the network or else they won't get paid. So they're giving us this viewpoint that, the people that make money from the network will pay for it because, of course, otherwise they won't make money. And in other blockchains, we often hear the same thing, but people will often talk about the companies that are offering services on the network. So companies like Infura or companies like BitPay. And we'll hear that, businesses will pay for the network or else they can't use it. And this sounds like common sense. Why won't people do things that make them money? Well, the problem is, if you remember our presentation on the tragedy of the commons, that it's not group interests that matter, it's individual interests. And the problem here is that even though it's in everyone's interest to cooperate, the social outcome is maximized. No matter what your peers in the network do, you are economically better off if you don't pay. And so if they're cooperating, you're going to defect. And if they're defecting, well, you're better off defecting as well. And this is something that almost nobody working in blockchain on the technical side of things, they're not aware of it. People have this very naive idea that, well, we need the blockchain to exist and it's making us money. So of course, markets will find a way to pay for it. People do not know market failures. And this is actually why proof of work and proof of stake networks, they're just not working. As we've talked about, what actually happens is if you put a network in this situation, the markets will solve it by privatizing the public good. Now, there are two ways you can solve free riding. The first is you can collude to punish defectors. And the second is that you can privatize the benefits. And the important thing to see, because we're actually seeing both of these right now, is that both of these close access to data flows on that network. If you've only got a small number of miners or block producers, they can team up and they can start policing the other participants of the network. The problem is that if you are doing that, you are by de facto running a permissioned chain. And you, by definition, have only a small number of actors, because as soon as you have a large number of actors, you can't collude to do that and your network's toast. The second thing, which is much more threatening, is the privatization of the value of the data and transaction flows. And this is something we're already seeing. In BSV, we've seen it with Weather SV, which has partnered with a specific miner to get lower fees. Now, people celebrated this in the BSV space as a big victory for market economics. They don't realize that what it actually is a market failure that is going to rip their network apart. We also saw the exact same sort of issue with Ethereum. We've been hearing from Ethereum developers that Infura is collecting a vast majority of the transaction fees. It's essentially losing millions every month operating an API access point for the world of network applications. So we've got a situation here where the miners who are supposed to be paying for the network are just refusing to do it. And the result is that if Infura wanted to attack the network, it could pull off a 50% attack anytime. So there is a solution, and this is the really exciting news. And it's also the part of what's happening with scalable blockchain that very few people understand because their focus is on the tech. And just like the solution to the tragedy of the commons problem, what we need to do to fix this problem is we need to change the incentive system. And we need to make it so that individuals have an incentive to do what it is that we want the group to do. And what that means is we need to make it so that the public network, the support of the public network, is what our blockchain actually pays for. And this is how Saito accomplishes it. The first thing we're going to do is we're going to create a measure of routing work. Now, routing work is not the transaction fee, but it's a value that we're going to derive from the transaction fee. So you can think of it as the value of the transaction fee divided in two with every hop that the transaction makes across the network. And we're using cryptographic signatures on the network layer so that people can't cheat doing this. So in this example, you can see that the first hop has 10 units, the second hop has 5, the third has 2.5, and the total amount of routing work in this 4-hop chain is 18.75. So we're generating routing work. And what happens is the nodes in the network, as they start moving these transactions around, the routing work builds up in their mempool. And it builds up at the key focal points in the network where the value is flowing in. So if you want to compete for money in a Saito system, what you want to do is you don't need to get really good at mining. You need to get really good at encouraging people to spend high value, high fee paying transactions. So as you can see, we've got essentially a supply curve and a demand curve here, and that's going to give us the average block time and the average amount of routing work. We refer to it here as the burn fee. The white paper is a bit clearer about this. And that's giving us a pace of block production. And what we're going to do is when a block is produced, we're going to play a game that holds a payment lottery. We've got something we call the golden ticket. You can think of this as a proof of work style mining solution. Just remember that we're not mining to produce blocks. What we're doing is we're mining after a block has been produced. And if we find a proof of work, a mining puzzle, a solution to that in time to broadcast so that it can be put in the next block, the money is going to get divided. And half of it is going to go to the lottery nodes that we're mining, and half of it is going to go to a routing node. And it's going to be picked, that routing node, importantly, according to the routing work, its share of all of the routing work that was put into that block. So we have a system where the mining nodes, well, their chance of winning is 1 over the number of mining nodes. And the routing nodes, you can see their chance of winning decreases as the routing path gets longer. But you've still got always an incentive to share those transactions if you can't put it into a block. One of the lovely things about this is that everyone in the system is always competing with their exact same class. Block producers are competing with block producers, miners are competing with miners, routing nodes are competing with routing nodes. And one of the critical things that's subtle about this is that we are eliminating free riding. Because if you take a look at the way we're measuring routing work, and then we're playing a game, and people are getting paid proportionally for the routing work that we're doing. But we're actually incentivizing nodes to do something very special. We're incentivizing them to contribute value to the network. This is something that does not make sense in proof of work or proof of stake. They don't know what value is. Value in a decentralized network that doesn't have an owner, value is the collection of money and the efficient provision of that money to the parts of the network that need to exist to continue collecting money. So the public infrastructure is actually the key source of value. It's what users pay for. And what we're doing with this system is we're incentivizing nodes to do whatever it takes to get users paying fees. And the question you should be asking is, okay, well, this sounds good, but is it secure? And the answer is yes. Is it secure against grinding attacks? Well, notice that neither block producers nor miners control the payment mechanism. What we are doing by having a two-part system where both parts are under competitive economic pressure is we're making it so that as soon as you can produce a block, or as soon as you do find a solution, you've got to broadcast that to maximize your chance of getting paid. And the result of that is you can't waste the time to try to game the system. And even if you could, what could you do? Block producers, they don't know what the miners are going to be able to find. So the block producers can't choose which routing nodes are going to get paid. And likewise, the miners, they can't control the blocks that are going to get produced. So they don't really have a head start. What about Sybil attacks? Well, Saito is actually the only blockchain that is fully secure against Sybil attacks. And what we mean by this is that economic pressures make it so that anybody who gets Sybiled becomes economically unprofitable and drops off the network. So if you can think of, in this visual, the second routing node is a Sybil. And what's a Sybil? Well, other networks, they don't even know how to define it. With Saito, we can say, well, we know what a Sybil is. A Sybil is a node that does not contribute the same amount of value to the network that it takes away in fees. In a proof of work or proof of stake system, that might be that it takes away in attacking or it imposes in bandwidth costs on the network. You can see here, though, that because we have cryptographically secure routing paths, not only can nodes identify that, look, this second hub, it's not doing anything. It's passing transactions, but it's not really collecting any new ones. And the network can route around it. And so we have economic pressures that are incentivizing efficient routing paths. What about 50% attacks? Well, this is one of the most wonderful things about having a distributed work gathering system. If you want to attack Saito, you need to, first of all, you need to match all of the outstanding routing work. Because if you don't spend 100% of the fees that the honest network is collecting, by definition, you can't produce a faster blockchain. But once you've spent 100% of those fees, you've locked them up. You also need to play this mining game. And if you're playing this mining game, the way the math works out, we've got mathematical papers on this, is that you need to do more than double the amount of mining that the honest network is doing in order to get any of your money back, essentially. And so we've got something that is secure. It has guaranteed costs of attack above the 50% point. And this is something that, to my knowledge, no other blockchain actually has. And finally, we should mention that we're secure against spam attacks. We have consensus rules on the network layer that can defend against block flooding and transaction flooding. Now that the mechanism has been outlined, if you're interested in it, you will probably understand the Saito white paper. people who are just dropped into it without an overview, it can be very difficult to see what's happening. I want to talk a little bit about some properties. First is that in Saito, collecting fees is the equivalent of mining. So if you remember at the beginning of this presentation, we talked about the importance of measuring value and paying for value. And this is what our network is going to optimize itself to do. Another thing is that cost of attack wonderfully is now scaling with transaction throughput. In all blockchains, proof of work and proof of stake, the security is paid for by 50% of whatever the amount of money is that's being spent on the consensus mechanism. So, if proof of work and proof of stake need to pay for the network, it's not even 50% of fees. If 50% of those fees go towards network infrastructure, you're actually only being secured by maybe 25% of fee throughput. In Saito, 100% of network fees contribute to security and contribute to that cost of attack. I'd encourage anyone who's interested really in geeking out over consensus mechanism design, take a look at our white paper, take a look at the paysplit, passsplit modifications, because we actually get security well above 100% to around in between about 125 and 150. Those details can be found on saito.io, saito.io. If you are interested in more economics, be sure to visit our economics page there. We've got a video there that explains another major problem in the incentive structure of existing blockchains and explains how to solve that. Encourage you to take a look. And thanks for watching.